Good evening, or I guess for many of you it's good morning on Thursday. Thank you very much for joining me today as I describe the addition of MODFLOW6 to Groundwater Vistas 7. My name is Jim Rumbaugh, and along with my brother Doug, we are the developers of Groundwater Vistas. And MODFLOW6 is the most recent release of MODFLOW by the U.S. Geological Survey. I'm told it's because it is the sixth major release of MODFLOW, which I guess makes sense. If you count MODFLOW 88 and 96 together, that would be one. MODFLOW 2000 would be two. MODFLOW 2005 would be three. NWT would be four. MODFLOW USG would be five. And so this would be MODFLOW 6. So tonight what I'm going to do is talk to you about MODFLOW 6 and share with you how we've implemented that in Groundwater Vistas. Three topics is what I'll cover tonight. I'll introduce you to MODFLOW 6 and its basic capabilities. We'll talk about what is supported in Groundwater Vistas right now and what may be supported in the future, and then what is missing, both from the MODFLOW side of things, from the USGS, and also from Groundwater Vistas, because obviously we're not supporting everything right from the start. So I'm going to go through this. And in the past, when I've done these webinars, I've taken questions as I go along, but in reviewing the recordings, it does make the presentation a bit disjointed. So what I'm going to do this evening is cover all of my prepared information first, and then I'll take as many questions as I can to fill up the hour. If I don't get to your question, I apologize in advance. If I do not answer your question, please feel free to send me an email after this is over. I will be uploading a recording of the webinar tomorrow or the next day. I did one webinar today at 11 o'clock in the morning, and this is the second one here at 8 o'clock at night. This one will probably be the one that I upload, but I'll make that decision tomorrow. You'll probably notice that all of you are muted, and that's because there are a lot of you on this webinar, and I don't want to have a lot of background noise in the recording. And questions will not be asked verbally, but you can post the question in your GoToWebinar interface. There's an area where you can type in a question that will show up on my screen here. And then, as I said, I will answer those at the end after I'm done with my presentation. So let's get started then. The first official release of MODFLOW 6 was around last August. There was a previous beta release, which was done in the spring and coincided with presentations on MODFLOW 6 at the MODFLOW conference last May in Golden, Colorado. Unlike previous releases of MODFLOW by the USGS, MODFLOW 6 is completely new. It's written in a new programming language, which is object-oriented Fortran. It has all new input formats and all new output formats. There is a lot of extensive documentation on it to help to ease you into this new version, and I strongly encourage you to read these manuals if you intend to use MODFLOW 6, because there are many things we take for granted in MODFLOW, especially if you're like my age and have been doing this for a long time. The previous versions of MODFLOW were pretty consistent in how they implemented various things. And MODFLOW 6 is different in some respects. So if you're going to use it, in addition to listening to this webinar, you really should read the manuals to orient yourself as to some of the new assumptions, perhaps some of the new options. I'll try to point out some of these as we go along, but I'm not going to be able to cover everything in this one presentation. MODFLOW 6 is very similar to MODFLOW USG in many ways. They both use the control volume finite difference technique, and they both support a wide variety of mesh types. All of the MODFLOW USG mesh types supported by Groundwater Vistas are also supported by MODFLOW 6 in its current release. So these include the structured grid, the normal MODFLOW row column layer orientation with rectangular cells, as well as triangular meshes, Voronoi polygon meshes, nested grids, quad tree grids, and so forth. Those are the ones that are supported by Groundwater Vistas. Any shape of an element can actually be used in both MODFLOW6 and MODFLOW USG, even if it's not directly supported by Groundwater Vistas. Although I will say there is an option in Groundwater Vistas to convert a polygon shapefile to a grid specification file, and from that file you could create a MODFLOW grid. So theoretically then you can create a grid that has any shape element in it. If you can imagine it and create it in the form of a shapefile, you could actually make a MODFLOW model out of it. But that requires a few extra steps. So the native mesh types in Groundwater Vistas are the normal MODFLOW grids, the nested grids, quad tree grids, triangular grids, and Voronoi polygon grids. Those are the main ones. One thing that's very new in MODFLOW6 is the idea that you can take multiple independent models and stitch them together into one simulation. This is similar, for those of you that know a lot about the various versions of MODFLOW. There is a version of MODFLOW called MODFLOW LGR, which LGR stands for Local Grid Refinement. This is something that Groundwater Vistas has never really adopted, mainly because I think MODFLOW USG does it much better by just embedding models together using nested grids and so forth. However, the multi-model design in MODFLOW6 is even better than LGR because it creates one matrix and solves all the models simultaneously. To do this, the USGS took the transient discretization, so the length of a stress period, the number of time steps, and so forth, that has been pulled out of the individual model, as well as the solver. The solver is now not pertaining to any individual model. It's used for the whole solution, which may include multiple models. So they've pulled those out. Those are independent of the models themselves. And that's because when you do stitch these models together, they all have to use the same stress period and time stepping scheme. So it kind of makes sense. Right now in Groundwater Vistas version 7, we do support MODFLOW6, but using only one model. We have not implemented yet the ability to stitch models together. We're still trying to figure out how to make that or how to present that to you, the user, so that it makes sense and it's relatively easy to do. It sounds simple, but it is rather complicated to accomplish. So that is an important feature of MODFLOW6. We just haven't implemented it yet. As I mentioned earlier, all of the input formats are new. So a lot of the same information that you entered for MODFLOW models before is the same, but the formatting of it in the input file is very different. And on the left, I just show you the documentation for what goes in the NPF file. NPF is the node property flow file, which replaces the BCF, the block-centered flow, and the LPF, or the layer property flow, or the UPW if you're using MODFLOW NWT. So those file types no longer exist, and we'd have this one file called NPF, which has essentially the hydraulic properties, horizontal and vertical K. Storage, you'll notice, is not in the NPF file. Storage actually has its own file, which I'll talk about in a minute. So the new format is dividing the file into sections. Each section has a begin statement and an end statement. Usually options are at the top of the file, and that's followed by the actual grid data. For regular grids, that data can be in layer format, just like it is in the MODFLOW versions you're used to now, or it could be in node order if it's an unstructured grid. Now, there's two things that took me a little getting used to in MODFLOW6, and that is, for the unstructured grid format, there is no concept of layers, and there is no concept of an inactive cell. So this makes the files a little more difficult to read if you're used to editing the files yourself. But if you don't do that, then it's all very transparent. The user interface for Groundwater Vistas remains the same. Vistas still treats everything in layer format. It's just that when it creates the input files, that layer structure goes away. The same applies to the inactive cells. You can still have inactive cells in your model grid, and when Vistas writes those input files, it simply omits the inactive cells in the list of nodes. So again, it's fairly transparent. It really only affects those of you that are used to working with the individual files. Just to give you another example, here is a drain package input file. On the left is the normal MODFLOW drain input that many of you are probably used to looking at. And on the right is the same file for MODFLOW6. And you'll see that instead of just being a bunch of numbers, it is broken up into logical sections. So it starts with some options. One of the options is to save flows, save the cell-by-cell flows to the binary files. There's also an option, or there's also a section which lists the dimensions. In the case of a boundary condition, it's just how many are there. And then for each stress period, it lists the boundary conditions that are active during that stress period. So it's pretty easy to read, and if you look at the individual data items, for example, the first drain is at layer 1, row 8, column 30, it's the same information, it's just formatted a bit differently. So if you're used to dealing with the input files for MODFLOW, it's not that difficult to deal with the input files for MODFLOW6. Output files are all different, as I said, and for those of you that have written utility software to read the output from MODFLOW, the binary output specifically, you will have to make a lot of changes. First of all of the binary information is double precision now in MODFLOW6. In the previous versions of MODFLOW, it was all single precision, although in some cases the USGS did have double precision versions. But in MODFLOW6, everything is double precision. The one file that remains relatively unchanged is for a structured grid. So if it's in row, column, layer order, the structured head save file has the same format except for the fact that the data are double precision. Cell-by-cell flow files are very different, especially for a regular grid. For a regular grid using rows, columns, and layers, unfortunately, the cell-by-cell flow files are written in an unstructured format. So it's a lot more difficult to read the cell-by-cell flows for a structured grid model. They're very comparable to the binary cell-by-cell flow files for MODFLOW USG. There is a new compact type 6 for boundary conditions. So this format's a bit different, but in general, it's similar to MODFLOW USG. But for those of you that have written utilities to read cell-by-cell flows from a regular structured grid, there's a lot of work involved in rewriting that software. There's also a new binary file that's written called a binary grid file, or GRB file, and that does contain all the information you need to understand the structure of the model. So if you're writing utility software, I think in a lot of cases it's going to be necessary to read that binary grid file first to understand what's coming in the other binary files. So a little bit more involved in writing utility software. Again, if you don't do that, it's no big deal because Groundwater Vistas deals with this behind the scenes and you don't really notice any differences. The one difference you will notice, at least for now, is there is no drawdown file. The USGS figured this was a post-processing step that anybody could do, but and they're right, it is a post-processing step, but it's an extra thing, and we just haven't implemented it yet in Groundwater Vistas. You can sort of get around this in Groundwater Vistas. On the plot menu, there's a submenu called File Operations. Within that menu is a function called Compare Two Files. So basically what it does is subtract one binary grid file from another, and you can subtract two head save files to come up with drawdown, for example. So there is a workaround, but it's not very seamless right now, and we will be working on that, but we have not implemented that yet. Now, that's sort of the basics of MODFLOW 6. Conceptually, it's very similar to previous versions of MODFLOW. It's just, the files are all different. So when you use this now in Groundwater Vistas version 7, and it is available now, if you have a license for 7 and go to our website and download the latest update, it will include support for MODFLOW 6, and it will include the MODFLOW 6 executables, so you can run MODFLOW 6 models. In terms of using MODFLOW 6, it's just like using MODFLOW USG in Groundwater Vistas. So if you've used MODFLOW USG, using MODFLOW 6 is essentially the same process. Right now, we do not have any Windows DLL versions of MODFLOW 6, so you'll be running command line versions. And there's 2 versions that we supply. One called mf6.exe, which is the default, is the command line version distributed by the USGS when you download MODFLOW 6 from their website. So it's coming direct from the USGS. We've made no changes. There's a second one called MODFLOW6-beta.exe. This we have recompiled from a GitHub repository the USGS has created, which allows people outside the USGS to see changes that are being made to the code, which is very nice. So they haven't officially blessed it yet, but they're allowing us to see bug fixes as they happen, which is very much appreciated. So what we do periodically is download the latest source from this repository, and I compile it and I give it a different name, so you know that this is one that has not been officially released. But if you do end up seeing problems with the official release, maybe you could try this, and perhaps whatever issue you're having has been addressed already. A couple of important notes on how MODFLOW 6 is used in Groundwater Vistas. Within MODFLOW USG, what we started doing in Groundwater Vistas 7 is we added an option called Only Write Active Nodes. And this is for the unstructured grids. And so if you have nodes that pinch out or inactive cells, Vistas omits those when it writes the unstructured grid. It just renumbers all the nodes so that it eliminates the inactive and pinched out cells. And that can be a big time savings in terms of runtime, because in a lot of models, you could reduce the number of cells by a factor of 2 or 3, and therefore you get a commensurate decrease in runtime. With MODFLOW 6, you have to do that. Well, I shouldn't say that. You have to do that if you have any inactive cells, because as I mentioned earlier, MODFLOW 6 does not have the concept of an inactive cell in an unstructured grid. So that gets turned on automatically when you switch to MODFLOW 6. The other thing that's a little different with how we treat MODFLOW USG is we do have full support for structured grids in MODFLOW 6. In MODFLOW USG, we really never fully addressed a structured grid in MODFLOW USG, figuring that the reason you're using MODFLOW USG is for the unstructured part. But in MODFLOW 6, we do have full support for the structured grids. These are the various packages that are available in MODFLOW 6, so it still uses the package concept, just like all previous versions of MODFLOW. Many of them are the same: wells, drains, rivers, general head boundaries, and so forth. And there are a lot of new ones. So there's a temporal discretization file, TDIS, that simply contains the number of stress periods, the length of the stress period, number of time steps, and so on. There's 3 different discretization files. DIS6 is for a regular MODFLOW grid, row column layer grid. DIS-V6 is for an unstructured grid where every layer has the same nodes. And then DIS-U is the totally unstructured grid. Currently, we do not support DIS-V. So I didn't see a huge advantage, and it is a very different way of looking at grids than Vistas is generally designed to do. So we support the DIS file, which is for regular grids, and then DIS-U for unstructured grids, but we do not do the disv yet. We may add that in the future, but I didn't think it was that important, so I didn't put it in there. There's the nodal property flow NPF, which I mentioned earlier, takes the place of BCF and LPF. Notice that storage has its own file. There's a storage file. And basically, if storage is provided to the model, then it looks for whether a stress period is steady state or transient. If there's no storage file, it assumes every stress period is steady state. Let's see. Another one that's a little different is MAW. So in MODFLOW 2005 and MODFLOW NWT, we had the multi-node well package. In MODFLOW USG, we used the connected linear networks for multi-layer wells. And in MODFLOW 6, we have yet a new package, which is the multi-aquifer well, MAW. And they all do about the same thing. They're probably slightly different in formulation, but they're, in general, they work the same way. Now, on the right are the other files or the other packages we do not yet support. So I mentioned disv. We have not supported yet the UZF package, although we will. The MVR package is called the water mover package, and that allows you to take flows from things like drains and put it somewhere else in your model, like recharge. We have not implemented that yet, but again, we will. Ghost nodes, observations, and then, as I mentioned at the start of the presentation, we do not yet support the use of multiple models. But all of this will be done in the future. We just wanted to get the basics finished and see how people are using MODFLOW 6, and then continue our development from there. The nice thing about MODFLOW 6 in terms of using these packages is you no longer have to provide a unit number. All you do in Groundwater Vistas is tick a box that says we're going to use that package, and no unit number needs to be required. We've also consolidated all packages onto one dialog. So, if you're using MODFLOW 2005 in Groundwater Vistas, you have to go to the MODFLOW packages dialog, the MODFLOW 2000 packages dialog, and the MODFLOW 2005 packages dialog to assemble all the packages for your simulation. MODFLOW 6 uses far fewer package types, and so it was simple enough just to put them all in one place. So that's what I've done. Another unique characteristic of MODFLOW 6 is the ability to split up many of the boundary conditions into multiple input files. So, for example, you may have a lot of wells in your model, but maybe you're really particularly focused on a group of wells in one area, maybe a certain well field. You want to be able to manipulate that easier. So you can split it into two well input files, one for the well field you're interested in, one for all the others. And so you do that by just simply entering the number of package files you want for these boundary conditions. And on the right is the spreadsheet where you would enter additional information. And the way the boundaries are segregated into these packages is by reach number. So in this example here, for the well package, I'm saying that reach 1 through 5 is a particular well field, reach 6 through 100 is everything else, and so I've split it up into two files. And that can make it very convenient, especially if you want to track the mass balance in the MODFLOW listing file, because these things are all split out in the mass balance, and also if you're used to working with the input files and editing them outside of Groundwater Vistas, it just makes it a lot easier. Now, we've implemented this ability to have multiple package files in wells, rivers, drains, general heads, horizontal flow barriers, constant heads, and multi-aquifer wells. We have not implemented it yet for recharge and ET, although we will in the not too distant future. You will have multiple arrays of recharges, because in a lot of cases you do have recharge coming from multiple sources, and I've had a lot of requests over the years to keep them separate. And MODFLOW 6 allows you to do that. I just haven't finished the implementation in Groundwater Vistas yet, but that is coming. Here are some of the most important options for MODFLOW 6. So there's a dialog of options, and tabs for different packages and so forth. The main tab has the main options, and the three I'm highlighting here that I think the most important. At the top is the mesh type, unstructured versus regular. There's an option to use the Newton method. So those of you that have used MODFLOW NWT and upstream weighting in MODFLOW USG, that same option is here. It's just called using the Newton method. And this is the one that keeps grid cells from going permanently dry. It maintains a very small amount of saturation so that they can seamlessly resaturate later in the run if necessary. So if you're comparing the results of MODFLOW6 to a MODFLOW NWT run or to a MODFLOW USG run that used upstream weighting, then you would want to turn that option on. If you're comparing your simulation to MODFLOW 2000 or 2005, then you should probably turn that off because it is a different formulation. And then at the bottom is the option I mentioned before that, because MODFLOW USG does not recognize inactive cells in an unstructured grid, you need to turn on that last option that says only use active nodes when you're dealing with an unstructured grid in Groundwater Vistas. The solver for MODFLOW6 is essentially the same solver as MODFLOW NWT and MODFLOW USG. So a lot of the input is the same. If you compare what's on this dialog with what's on the NWT solver dialog, which is the NWT solver, or the MODFLOW USG dialog for the SMS solver, you'll see the same sorts of information. There's just a little bit of a difference, and that is the degree of complexity, which is simple, moderate, or complex, also includes a default value for the head change criteria and the maximum outer iterations. And a lot of times you're going to want to change those. I know in our testing of MODFLOW6, when I compared it to other runs I had done with other versions of MODFLOW, I needed to be able to change those. So what we've done is put in an override, which is this checkbox here that says override complexity option. So what this means is what you see on this dialog says use a moderate degree of complexity, but instead of using the default head change criteria and outer iterations, use the ones I've entered. And I think that's what you will use most of the time. At least that's the way we have it set up now. That's the way I've used it in my testing, and I think that works the best. Another very new option in MODFLOW6, which I think will be very popular with people that deal with fracture flow systems, is the ability to specify the three-dimensional conductivity tensor. In all previous versions of MODFLOW, you specify a KX, a KY, and a KZ, and they're always assumed to be parallel to the axes in the model. With MODFLOW6, you can turn on this option called XT3D, and in that case, you still enter a KX, a KY, and a KZ, but then you also enter 3 angles of rotation. And in MODFLOW6, it's just called angle 1, angle 2, angle 3. And those then allow it to assemble the complete 3D tensor for hydraulic conductivity. So all the components of conductivity are supported. And that can be defined cell by cell. In Groundwater Vistas, those angles for the XT3D formulation are in the fracture property. And I'm not going to try to describe what angle 1, 2, and 3 are. I think you should there's a whole documentation on XT3D, and if you're interested in that, you should read that manual. But Vistas does have the ability to enter all the information needed for XT3D. So that's the basics. That's what MODFLOW6 does. That's what Vistas supports and what it doesn't support. So what are the other things that are missing? And I think the 2 main things are at the top here. The transport is not supported yet, and particle tracking is sort of supported, but not in Groundwater Vistas. ModPath version 7 apparently supports rectangular grids for particle tracking in MODFLOW6. We have not tried this yet. We have not supported this yet. We will eventually, probably. But it's not there yet. There is no transport at all for MODFLOW 6. I had questions earlier today about whether it works with the new USGS version of MT3D. No, it does not. It does not work with the transport package in MODFLOW USG. There's simply no transport yet. The USGS does have this in their plans to develop. It's just not been done yet. One thing I'd really like to have in MODFLOW 6 is the connected linear network package from MODFLOW USG. We do have a component of that in that the multi-aquifer well package is very similar to a CLN well, but we don't have the ability to use connected linear networks for fracture systems or surface streams and things like that. So that I hope will be developed, but I don't really know that. And then the drawdown calculations, as I said, MODFLOW 6 does not write a drawdown file. So that's something we will have to add within Groundwater Vistas after a run is finished. If you check the box that you want drawdown, Vistas will have to do some sort of calculation to come up with that. I have not done that yet, but again, it's on the list. It's just a missing piece of the puzzle right now. So that is, what I wanted to present this evening. And so if you have questions, please feel free to post those into the question area, and I'll, as I said earlier, take as many as I can. We did get a lot of questions this morning, and while I'm letting you think about it, one of them was, does Groundwater Vistas allow you to use PEST with MODFLOW 6? Yes, it does. All aspects of PEST work with MODFLOW 6 just like it does with all the other versions of MODFLOW, including pilot points. The only real distinction would be if you're using a regular MODFLOW grid, so a row column layer type grid with rectangular cells, and you use pilot points, instead of using the factorial type kriging programs that come with PEST, we use PLProc, which is another utility John Doherty wrote to do kriging for unstructured grids. So even though it's a structured model, we still use the unstructured PLProc. Another question is there a version of zone budget for MODFLOW 6? Yes. Well, I guess there's two parts to this question. Groundwater Vistas does mass balance just like zone budget internally, and it works just like all the other versions of MODFLOW. So yes. But the USGS also does have a new version of zone budget to work with MODFLOW 6. Groundwater Vistas just doesn't use that. So you're welcome to use it if you want, but we have not implemented any connection to it. Next question is, can I explain which of the mesh types rely on alga mesh gridding and which are native? So alga mesh, that's a good question. Alga mesh is used to create triangular grids and the Voronoi polygon grids, and those work both in MODFLOW USG and in MODFLOW 6. The native types are the nested grids, the sub-layered nested grids, and the quad tree grids, and of course the regular row column layer grids. You could also do triangles and Voronoi polygons and so forth if you can somehow get those into a shape file in GIS. I know some of the GIS software has some rather complex topological features that would allow you to create a mesh. And if you can do that as a polygon mesh, there is a function in Vistas to convert that shape file into a grid spec file, which can then be used to start your grid in Groundwater Vistas. So you don't need alga mesh for that if you were able to do that. That there is a way of sort of getting strange looking grids into Vistas without using alga mesh. Another question is, what about representation or support for urban runoff packages? I imagine you could use the UZF package for that. UZF does have a runoff component. You can, if recharge is rejected, because let's say vertical conductivity in the soil zone is very low, you can tell it where that water runs off. Now, we don't support UZF in MODFLOW6 yet. We do in MODFLOW NWT and MODFLOW 2005, and we will support it in MODFLOW6. We just haven't gotten to it yet. It's a rather complicated package, and I didn't want to hold up the initial release for it because there aren't that many people that use it really. Okay, the next question I also got this morning, and that is, from my experience, what are the major advantages of switching to MODFLOW6 from MODFLOW 2005? I really don't have a tremendous amount of experience with it yet because it's just been out a few months and I've just been testing it. But I will say there are a few unique qualities to MODFLOW6 that, if they're important to your project, would be a reason to switch. One is that XT3D. If you have a real need to be able to adjust the anisotropy angles within a model to follow some sort of fracture zone or whatever, then that would be a good reason to switch. If you want the convenience of being able to separate boundary conditions that represent certain features in your model so that they're in their own file and are reported in the mass balance separately, then that would be a reason to switch. I have noticed that the solver for MODFLOW6 seems to be particularly good. I say seems to be because with these complicated solvers, it's very difficult to know whether you've totally optimized the solver for runtime or not. So there were a couple of models I tested, which are big models, and one, well, okay, I'm going to caveat this as I just said, where I can't guarantee you that I totally optimized the solver in the original run, nor did I do too much to try to optimize it in the MODFLOW6 run. So bearing that in mind, one run took 24 minutes to run with MODFLOW 2005, and MODFLOW6 did it in 7 minutes. Another one, which is a huge run, millions of nodes, took 1 hour and 37 minutes to run with MODFLOW NWT, took 50 minutes to run with MODFLOW6. So it's not a very exhaustive comparison, but I have been pleasantly surprised at the speed of the solver. And it is pretty easy to use by just changing from simple, moderate, and complex, and then adjusting the number of iterations and so forth. It's pretty easy to use. So those are some things that I've noticed. I think once we get the model stitching together, there may be some advantages to that. If you have different models that overlap in an area and you want to be able to put them all together, that's a very unique characteristic. And but again, that'll take a little longer for us to implement. Another question is whether the farm package is supported. No. That's only supported in, what's that version called? MODFLOW OWM, OWM, I forget what it stands for, One Water or something like that. And we don't support that in Groundwater Vistas either yet. We may eventually do that. I keep saying we may do that. It's a very complicated package, and we haven't done anything with it yet. Another question is, does Vistas allow to create grids or cell sizes based on input statistical parameters? For example, to create features that represent fractures based on spacing, length, aperture, and so forth. No, we don't do anything like that. Another good question is, does MODFLOW6 have a TVM package, the transient material properties packages, or time varying materials, I guess is the MODFLOW USG equivalent. No, it does not. And I honestly don't know if that's on the USGS radar or not. When you look at versions of MODFLOW that have that now, it's MODFLOW USG, and Damian Merrick wrote that one specifically for MODFLOW USG. And MODFLOW Surfact has one, which is the TMP package. So those are the only two versions of MODFLOW that have such a thing, and the USGS didn't write it. So I don't know if that's going to be important to them or not. It is very useful, I'll agree with you. There are certain cases where that's extremely useful, but it's certainly not in there now. Now, Damien's a smart guy. Maybe he can develop one for MODFLOW 6, although he's going to have to learn object-oriented Fortran to do that. Now, let's see. Next question. Is there an unsaturated option available in MODFLOW 6? No. The closest would be the UZF package, and that's not really unsaturated flow. I mean, kind of is, kind of isn't. It's like a one-dimensional unsat approximation within the Vados zone. It's not really unsaturated flow the way MODFLOW USG and MODFLOW Surfact does it. So no, they don't have that. And then the last question that I've got so far is, I think I just answered it, but I'll answer it again, is there a zone budget for MODFLOW 6? Yeah, yes, there is. And Vistas also, Groundwater Vistas also does the same sorts of calculations internally. But the USGS did write a zone budget program for MODFLOW 6. Another question is subsidence package, whether that's available in MODFLOW 6. No. In fact, let me just go back. So the packages that you see on this dialog on the left side of this screen, those are the only packages available in MODFLOW 6 right now. The ones that are grayed out means we don't support them yet. But I'm pretty sure everything that is available for MODFLOW 6 is on this dialog. So yeah, there's no subsidence, there's no multi-node well, but there is the multi-aquifer well, so it's sort of the same thing. Trying to think if there's others. Oh, one thing I'll mention is it does have the lake package, but it's a very different lake package from the previous versions of MODFLOW. In the previous versions of MODFLOW, when you put a lake in the model, you made the cells that contain the lake inactive. Now, this sort of happens behind the scenes, so maybe you didn't realize that. But the lake in previous versions of MODFLOW is assumed to fully penetrate the cell so that there's no aquifer flow within the, below the lake, essentially. With MODFLOW 6, you can do it either way. You can make the cells inactive or not. So I've had to add an option in Vistas to do that. If you don't make them inactive, essentially what it means is the lake sits above the grid cell. So it's, let's say a partially penetrating lake that is at or near the water table, for example. All right, and I think I'm caught up. Any other questions? I will also mention that MODFLOW 6 is, what the USGS considers their definitive version of MODFLOW. And I'm pretty sure most of their development efforts are aimed at MODFLOW 6 right now. So for those of you, a common question, I got this question a lot this morning is, do I think you should switch to MODFLOW 6? Well, I can't really answer that. It is new, and I've always been a little reluctant to switch immediately to new versions of MODFLOW. But having said that, I have tested it pretty thoroughly on a number of very huge models, real world models, plus just comparing it to other versions, and It seems to work very well, and I like the solver. It seems to be very efficient. So, I don't think there's I guess I'm not as hesitant to use it as I would have been in the past, except for the fact that there are some things missing like transport and particle tracking. But so far so good. I think it's pretty well done. It is a little bit of a problem in that it's written in object-oriented Fortran, and I don't know object-oriented Fortran. I mean, I can compile it, but it's not like I would work too hard at making changes to it. Of course, we've never really changed MODFLOW very much for Groundwater Vistas anyway. We've always had the philosophy of keeping it as true to the native version from the USGS as possible. So that's not such a big deal. And someone asked, have I used it much with unstructured meshes? Well, I have. Yes, I've tested it with all these unstructured mesh types, and it so far I haven't really had any issues with it. Well, I shouldn't say that. I haven't had any issues with it except for my own conceptual misunderstanding. It's funny, but it took me quite a while to realize that it did not have inactive cells. That's a little embarrassing. I should have figured that out right away, but I didn't. And a few questions to the USGS, who have been very good at answering all my questions. And I realized, my mistake, but fortunately I had already implemented that option for MODFLOW USG to drop out the inactive cells. So that was not a big deal. It's just one of those conceptual misunderstandings. Oh, someone just asked, so I said that packages not available are grayed out in MODFLOW 6 dialog box. Does that mean using multiple package files for recharge and ET is not available? Yes, that's correct. We will have that, but we don't have it right now. Because that means I have to duplicate and essentially make an array of recharge arrays. And it's a little tricky, and I just, again, didn't want to get bogged down in that to start. We will have that option at some point, and it probably won't be too far in the future. But you're right, it does not exist right now. Another question was, aside from particle tracking and transport, are there any other conceptual situations that currently would not be good to model with MODFLOW 6? Well, I mean, there are certain specialty packages which aren't supported, like someone had asked about subsidence. So we can't simulate subsidence right now. We don't have the connected linear network, so we can't do fracture networks, and we can't do, linear surface water features except using the stream routing package, the SFR package. So there's certain things that, it doesn't really have the capabilities for right now, but, for most groundwater situations, it has what it needs. Another question is, any other developments coming in Vistas 7 besides new MODFLOW 6 packages? Good question. I don't know. I've been so focused on MODFLOW 6 the past couple months that I'm not sure. And that's going to be my focus for a while yet, because there are some things I do need to implement, like the multiple recharge packages, UZF, things like that. So for the next few months, it's really, Vista's development will be focused on MODFLOW 6. All right. Unless there's any other questions, I do appreciate you participating this evening. And as I mentioned, I will be uploading a recording to our website. So that will be groundwatermodels.com. And if you click on the clients/downloads button and log in, expand the file list, it'll be sort of way at the bottom of the list of files. All right, I think we'll end it there then for this evening. And if you do have questions, I think I did get to most of them. If there are other questions I did not address, please feel free to send me an email and I will respond to those tomorrow. So hope you have a good day. If your day is just starting, hope you have a good day tomorrow if your day is ending. And I'll let you know when we have another one of these webinars in the future. So thank you very much.